Rightio, so let's continue with where I get cut off when I get to 15 minutes, you see. So we have, we're up to B, aren't we? Calculate the distance between Hannah and Brent, so that's where we're up to next. All right, so we're on page 48. Calculate the distance between Hannah and Brent. So we're looking now at finding that distance from B to C. Okay, so we're looking at this line here from B to C. We've worked out that this is 106 degrees, and we know a whole bunch of other stuff there, don't we? All right, so we've got 150, I better put these in, and 150, and 37 down here, so this guy down here, he's 37 as well. All right, so right now, this is not a right angle triangle, is it? We're wanting to find a distance that's going on. With these angle rules that we've been learning so far, they're all to do with finding angles. They don't help us with regards to finding lengths. So if we're wanting to find a length, it's probably going to need to become a right angle triangle somehow, okay? This isn't a right angle triangle, but we could make some right angle triangles, eh? So if we were to bisect this triangle, just boom, 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 right down the middle here, to form 90 degrees on both sides, we would have two beautiful little right angle triangles, okay? And so from there, hopefully you can see how you could use trigonometry, okay, to figure out BC, okay? You're going to end up with the same amount because they're both the exact same little triangles, aren't they? So you're going to end up with a certain amount from, say, B to this point in the middle here, and then you can just times that by 2 for that whole distance, okay? Question C, calculate the bearing from Hannah to Brent. So, yeah, from Hannah to Brent, we've worked out Hannah was the one that had the longest bearing. So she's over here at point B. We're wanting to know the bearing to this line here, where she heads up here to Brent at point C. Yeah, this is where they have made a slight error in the book, and you just need to watch this. They don't need to do all that end bit. In the book, they've actually done the bearing from Brent to Hannah. Okay, that's what they've actually calculated. So if we're wanting to do from Hannah to Brent, we can have a wee look. And what did I end up doing before? Oh, yes, so we've got our parallel lines, all three lovely little parallel lines going on. We know from the very beginning that that bearing around to that line is 102 degrees. So therefore we know this guy here, don't we? We could work that one out. We've got parallel lines going on. They're co-interior. So we can just do 180 minus 102. So we've got 78 degrees for that angle there. That's good to know because we also know that this guy here, what was it again? 37. Okay, this wee guy here is 37. That part there is 38. So add the two together because notice again here you have got parallel lines. This guy here and this guy here. You've got a line running along there. We've got angles and parallel lines. Okay, we can use our rules again. So if we add up 78 and 37, what's that going to be? 115. Then this guy here is co-interior with that 115. So that will end up being, whatever it's going to be, 65. My brain's gone to sleep. 65 degrees. Okay, because it's co-interior, it's a bearing, so it needs the 0 in front of it. So and just write down step by step, you'll see there that they've worked out the 78 degrees because of co-interior angles. You would then work out you would then say 78 plus 37 degrees, and then say you've got the 65 because it is again co-interior angles and parallel lines adding up to 180. You'll see what they've done there because they were doing it for Brent is they've actually gone around this way. Okay, they've worked out the 78 And then they've gone around. They've said, okay, well, it's 360. So all the way around, minus that 78, minus that 37 to just get them to here. And that's how we would attack a bearing that was like that. Okay? Cool, thank you. Okay, wow. So enjoy the bearings questions. It is really nice, and it's not too much that's actually new. It is just using those parallel line rules and some of those triangle properties to answer real life kind of applications. Cool, thanks guys.